Hello, hello. I am so excited to be doing this again. So this time around, we're going to do like three different types of problems. So I'm hoping that this helps. Remember, you can always pause this, rewind it, slow it down, whatever needs to be done. And let's get started. So the first one it's asking us, or the first four, it's asking us to find each product, which is multiplication, and it says cancel common factors before multiplying and show your work. So we're going to use some cancellation that's going to really help us, which is a little tricky. Now, I'm going to say this, and I want to be very clear that your teacher is probably wanting you to do something different. And if that's the case, do it the way your teacher is teaching you. Now, me personally, I don't mind if you stay on a problem 3, 4, 5 even minutes longer than you have to, just in case, like you need to check yourself again. So we're going to do the problem, and then I'm going to show you where you can do some canceling, okay? So let's first start. Remember, you multiply straight across. And I'm guessing that your teacher lets you use a calculator. I'll be doing everything by hand so you can just see some extra work. Okay. So we know 5 times 12 is 60, but we might not know our 13s. I know I use those anchor numbers that we talked about a long time ago, but I know that 4 times 12 gives me 48, 48, 49, 50, 51, 52 is going to be the 4 times 13. So we now want to reduce. Remember, anything that ends in a zero is divisible by 5, and also it is an even number. 52 is an even number. So first we're going to start by dividing by 2 on the top and the bottom. So half of 50 is 25, half of 2 is 1. So I say 25 plus 1 gives me 26. Half of 60 is 30. Again, these are even numbers. I'm going to divide by 2. Half of 26 is 13. And then half of I'm sorry, I said the answer already. Half of 30 is 15. So as you can see, our answer is done here because there's really nothing else that goes into both 13 and 15. So final answer is 13/15. Now, if you wanted to, you could definitely do some cross multiplication or cross dividing or cross canceling with the 4 and the 12. Usually I try to look for numbers that are even first because that really helps. So if I cut 4 in half, that would be 2. And if I cut 12 in half, that would be 6. So we have 2 over 5 and 13. Oops, I put equals. Back that up. Times 13 over 6. And it's going to be the same thing. You multiply straight across 2 times 13 and then 5 times 6. And so you would see that you would get the same problem. But like I said, if your teacher has you doing some extra stuff that I might not be doing, please do that instead. Okay. Let me just why is that so scribbly? There we go. So now you can see we pick up here. Okay, let's move on to number 18. We're going to do the problem first, and then we'll look and see where we can do some cross canceling. So 5 times 11 is going to give me 55, and 7 times 10 is going to give me 70. So from here, we are going to simplify. Remember, if anything ends in a 5 or a 0, we know it's divisible by 5. So 55 divided by 5 is going to give us 11, because remember, 5 times 11 gives us 55. So now let's do 70. 5 times, and this is one that's probably not off the top of your head, but you can always do long division, is going to be 14. So we have 11 over 14. Now, 11 is not even, 14 is. 11 doesn't have anything that's divisible by itself because that is like at its final point. So the final answer there would be 11 over 14. Now, where could we do some simplifying? The 5 and the 10. So if you wanted to, you can divide by 5, which would give us 1 on the top. And then 10 divided by 5 is 2, so it would be 11 over 2. 11 times 1 is 11, and 7 times 2 is 14. So as you can see, that's how we got there. So a lot easier if you can do some cross multiplying. But sometimes it is a little tough, and it's okay if you need to take a little extra, time on the actual problem. Okay, let's look at number 19. So 19 is a funny one because it's a whole number. Remember, anything that's like this, we just put a 1 up underneath it. This blue is a little hard to see. Let me change that to black. Okay, so we have 11 over 1 times 4 over 3. So now we can, there's actually no cross multiplying that I can think of, or cross simplifying that I can think of. So we're just going to multiply straight across. 4 times 11 gives me 44. 3 times 1 gives me 3. So now I ask myself, how many times does 3 go into 44? And I know that 3 times 12 is 36. So we can even go higher than that. 3 times 13, and I just count 36, 37, 38, 39. I know 3 times 14, 39, 40, 41, 42. That is probably the closest that we are going to get for sure, with it being 42. So 3 times 14 is going to give us 42, 43, 44. I'm left with a remainder of 2 over 3. Okie dokie. That one does not simplify anymore. 2/3 is as simple as we can get because there's not one number that goes into both 2 and 3, other than 1. All right, number 20. Last one on this page, and then we'll move to another section. Okay, so I'm looking at this one, and I'm pretty sure your teacher would want you to do 4 and 4, but it might make it a little weird. So let's just do it without doing the cross canceling just for just a second. So we're just going to multiply straight across. 4 times 7 gives me 28, and 4 times 5 gives me 20. So, of course, we have 2 even numbers. Remember, I want you to always, always point out those even numbers like, they're both even. Like, really count, like, call those out. So, I have 28 on the top. I can divide that by 2. And I have 20 on the bottom. I can divide that by 2. If you wanted to, and you really feel confident, go through your fours, like count through your fours and see if you hit 28, see if you hit 20, because that could also help with reducing as well. So with 28, half of 28 is 14, half of 20 is going to be 10. And then I can do this again. Oh, that kind of rhymed. And half of 14 is 7, and half of 10 is 5. So my final answer before I do the changing it to a mixed number, if I could talk, would be 7/5. But now I have to ask myself, how many times is 5 going to 7? One time. 1 times 5 is 5. My remainder, 5, 6, 7, is 2. So it's 1 and 2/5 as my final answer. And I'll say this, if you want me to go a little bit more in depth for this, just drop me a comment, flag me down, say something because we can really slow this down if this is a little tricky. But yes, that is it for 1 and 2/5. Pretty good, pretty good. All right, let's go to the next section. So the next section is wanting us to fully reduce the fractions. The first one that we have is 36 over 90. And it looks like that is done perfectly. So you cut those numbers in half. You have 36 cut in half, and you have 90 cut in half. Um, it looks like you have that perfectly. So, but let's work it out again for a second time for just safe measures, okay? Let me get out my little pen. All right. So half of 36, actually, I'll write down here so I won't write on top of your work, is 18, and half of 90 is 45. That's actually one of my favorite little numbers to cut in half, and you'll definitely see why in geometry, because every 90-degree or right angle is like 45 is the bisector, which is also just something that is just works out beautifully. So now we have 18 and 45. So we're trying to figure out a number that goes into both 18 and 45, which in this case would be 9. So I divide the top by 9 and I divide the bottom by 9. And I get 2. 18 goes into 9 two times, or you can think of it as 2 times 9, which gives you 18. And then 45 divided by 9 gives me 5. And the way that you can think about that is 5 times 9 gets you 45. Okay, so let's look at this next problem, number 8. Oh, sorry, I didn't circle that. Final answer, 2 pence. Okay, the next one is 90 over 144. So we're looking for two numbers that go into 90 and 144. Now, of course, the first number that I think of when I look at 144, I know 12, like I know it's divisible by 12. So I can say to myself, like, 12 times 12 definitely gets me 144, you know? Let me pause this. Sorry about that. I am having a birthday party tomorrow, so there might be a little bit of background noise. But okay, so remember, I want you to always pick out those even numbers. 90 is an even number, and so is 144. So we're going to divide both the top and the bottom by 2. We are now left with 45 is on the top, and as you have it right there, 72 is on the bottom. Now, there's no number that goes into a 5 that's even. Like there's not a 2 or a 4 that goes into 5. So the one things that I always try whenever a number ends in 5, of course 5, but 0, I'm sorry, 3, and also 5. Yeah, like those are like the numbers that I would try. So I'm gonna try by 5. When I divide 45 by 5, I'm pretty sure it's 15. I do not have my calculator. Um, let's just do it by hand. So 3 on the outside, and you can speed through this if you have your calculator. 45, 3 times, I'm pretty sure it's 15, because if I do 3 times, I'm thinking in real time here. If I do 3 times 12, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Yep, 15. Okay, sorry about that. 3 times 15 gives me 45. Now let's do 72. Okay, I actually might have to write this one out. That is the worst 3 ever, but don't mind that. Okay, so 3 into 72. So 3 goes into 7 2 times. 2 times 3 gives me 6. And when I'm left with a remainder of 1, I bring down the 2, which makes it 12. 3 goes into 12 4 times. 4 times 3 gives me 12, and 12 minus 12 is 0. Okay, so the bottom number here is 24. So we now have 15 on the top, 24 on the bottom. 15 is not divisible by 2 because 24 is even. That's the first thing that I would think, but it is divisible by 3. 3 times what gives me 15? 3 times 5. So I'm just going to put divided by 3 since you know what I'm doing up here. And remember, whatever you do on the top, you do to the bottom. And then, yeah, 24 divided by 3 gives you 8. So yes, this is absolutely correct. Okay, let's move to the next one. So this is talking about greatest common factor and finding the prime factors of each number. Now, later, you're going to be using like squared numbers and a whole bunch of other different things, and that could get a little tricky, but I'll say this for now. Anytime you see like greatest common factor or prime factorization or anything like that, I want you to think trees. Like I want you to think like trees with the branches because that's probably going to be the easiest route. So, first we're going to find the 78 and 84. We're going to find how to because what we're doing is we're comparing, okay? So with prime factorization, we need to break down each number into its prime factor. And then we are going to figure out which one of the prime factors they have in common, and then we multiply those together, okay? So I'm going to start off with 78 over here. And remember, we're making little branches, okay? So we're going to divide 78 by 2, okay? So I'm just going to put a little divide by 2 right there. When I cut 78 in half, let's see, half of 78 is 39. And then 39 can be broken down and divided by not 2, but let's try 3. 3 goes into 12. I mean, 3 times 12 is 36, 37, 38, 39. So 13. So I have a 13 there. And then 13 is a prime number, so there's nothing else that we need to break down there. So we are just going to stop it right there. So the next number is 84, and we're going to do the same thing. So I'm going to start because this is an even number by breaking it down by cutting it in half. Half of 8 is 4, half of 4 is 2, so 42. 42 again is an even number. It's divisible by 2. So I'm going to divide that by 2. Half of 4 is 2. Half of 2 is 1. 40, oh, 21. I don't know why I was writing 40. 21. Okay, 21 is a multiple of 3. So this time we're going to divide by 3. 21 divided by 3 gives me 7 because remember, 7 times 3 is 21. And this is a prime number. So we're done here. And so I'm just going to circle it there. So the prime factorizations that we're pulling out of this, let me change my color. For the first one, it was 2, then it was 3, then it was 13. Okay. For the next one, it was 2, then again a 2, then again, oh, a 2, and then a 3, and then a 7. Okay. So what we're doing, we're thinking what they have in common. They both have a 2 in common, and they both have a 3 in common. Okay. So the 2 and the 3 is what we're multiplying because they both have a 2 and a 3. So 2 times 3 gives us 6. And we are done with that one. Yeah. So the greatest common factor of 78, 84 is 6. That's what they have in common. And whenever they say anything about factoring, you want to think branches. Okay. All right. Let's move on to the last one of this video. Look, if you have been hanging in here with me this long, I appreciate you so, so very much. Let me go ahead and clear this out, and we're going to write these numbers now. So we have 72, and then I'm going to write this one 27. Okay. So we're going to do the same thing. 72 is definitely divisible by 2 because it's a what? An even number. So half of 72 is 36. And then 36 is also an even number. So we're going to divide that by 2. And 36 cut in half is 18. It's also an even number. So we are going to divide it by 2. Okay, so This one is going to be 2, 2, 2. Oh, and then we have a 9, and that's what I'm thinking. That's what I'm thinking is divisible by 3. And then that one is 3 times 3 gives me 9, and then that one leaves at 1. So our numbers right here, and I'm going to circle this for you, is going to be 2, 2, another 2, 3, and then, of course, the very last 3 at the bottom. Okay, let's do this next one, 27. Oops, why am I writing in black? Okay, so 27 is definitely divisible by 3. If I say 3 times what gives me 27, it's 9. So if I divide it by 3, I'm going to get 9. And 9 is divisible by 3 because we just did that one. So I divide by 3 and then I'm going to get 3. Wow, that one was a lot better. So these numbers, let me change my color again. And so we have 3, 3, and 3. So we have 2, 2, 2, 3, and 3. And then we have 3, 3, 3, and 3. So of course, our numbers that we have in common that's on this side and this side is 3. 3 and 3. So 3 times 3 give us 9. And I'm going to write this right here. 3 times 3 gives me 9. So the greatest common factor of 72 and 27 is 9. I really hope that helped. All right. Well, thank you so much for watching, and I will see you soon. Bye. Thank you for staying this long.